So we just have one thing to talk about in chapter 13. We're not going to cover all of chapter 13. So I do want to mention real quick solutions, and then we'll talk about molarity. So solutions we've talked about, we've learned about, especially in lab. We know that a solution contains a solute and a solvent. There we go. So intermolecular forces determine if a solution is going to form. So if there's interactions between the solute and the solvent, it's going to, the solution will form. And we're not going to get into all of that. But just know that intermolecular forces play a big role in whether the solution forms or not. Okay, there's three types of solutions. There's a saturated solution, which we actually talked about in lab. Saturated solution is holding as much solute as it or the solvent is holding as much solute as it possibly can at that temperature. So we said that, if you you're dissolving solute into the solvent and it stops dissolving, you have a saturated solution. That solvent is holding as much solute as it can at that temperature. So remember, temperature plays an important role, because if we change the temperature, it changes the solubility. So if I increase temperature, for the most part, we can dissolve more solute into the solvent, okay? An unsaturated solution is that the solvent can hold more solute than it is at that temperature. So if I put in the solute and it dissolves into the solvent, I know I have an unsaturated solution, and I can continue to add more solute. And then supersaturated is where the solvent is holding more solute than it actually should at that temperature. Okay, last thing I want to talk about is molarity. Molarity is just a way to measure concentration. And when we talk about concentration, we're talking about the amount of solute that's present in the solution. So there's lots of different ways to measure concentration. Molarity is just one of them. And it's represented with a big M, and it's moles of solute divided by liters of solution. Okay. So we have an example here. It says calculate the molarity of a solution made by putting 15.5 grams of sodium chloride into the beaker and adding water to make 1.5 liters of sodium chloride solution. Okay, so we need moles of solute and we need liters of solution. Well, they've already given us liters of solution, right? It's 1.5 liters. So all we have to do is go from grams to moles to find our moles of sodium chloride. So they do that right there, 15.5 grams divided by its molar mass, 58.44 grams, gives us 0.2652 moles of sodium chloride. So we just divide the two, and the concentration of our solution is a 0.177 molar. Okay, so again, there's lots of different ways to measure concentration. Molarity is just one. Now let's look at your worksheet and do the problems from there. Okay, so we have molarity is equal to moles solute divided by liters of solution. Okay, so number 8 says calculate the molarity of each solution. So we have 1.54 moles divided by 22.2 liters. Okay, and that gives us 0.0694 molarity. Okay, and then B, we have 0.101 moles divided by 6.4 liters gives us 0.0158 molar. Okay, number 9 is a little bit different. It says how many moles of sodium chloride are contained in each solution. Well, it's going to give us the molarity, and it's going to give us the volume. Okay, so we can rearrange this. And if we want to solve for moles, we need it to be by itself. So I just have to move liters over here, right? So we're going to get moles is equal to molarity times liters. Okay, do that up here. Okay. So we have moles is equal to 1.5 liters times 1.2. And you can use a big M, but in cases like these, I like to go ahead and put moles per liter so I can see the liters cancel and I'm left with moles. You don't have to do that. It's just, I'm all about those conversions, you know, so that's kind of how I like to set it up. 1.8 moles is what we get. Okay, and then the next one, we have 0.85 moles per liter. That's our concentration, times our volume is 0.448 liters. So again, make sure that volume is in liters. Liters cancel, and I get 0.38 moles. And that's it.